Math Blast 32, Tuesday. I can compare numbers in standard, unit, and expanded form. Use the correct relational symbol to make each sentence true. At first, I'm seeing two numbers that are written in standard form. Each digit is represented in its own place value. So I'm going to compare those digits starting with the greatest unit. In the hundred thousands place, both numbers have a 1, so as of now, they would be considered equal. Moving on, I see a 5 in the 10,000s place for both numbers. There's an 8 in the thousands place for both numbers. It isn't until we get to the hundreds place that I see a 4 and a 6. 4 hundreds is less than 6 hundreds. So 158,467 is less than 158,647. 2 tens and 35 ones. Here I have unit form. I'm going to represent those two numbers in standard form. 2 tens means I need 2 to end in the tens place. That means there would be no ones. That has a value of 20. 35 ones means I need the 35 to end in the ones place. That just has a value of 35. Now I can compare, starting with the greatest unit, 2 tens versus 3 tens. 2 tens is less than 3 tens. So 2 tens or 20 is less than 35 ones or 35. 4,000 plus 100 plus 90 plus 3 compared to 4,000 plus 100 plus 3. Those numbers are written in expanded form, and I can see that in both numbers I have 4,000, I have 100. It is here at this 90, there are no tens here, and then both numbers have a 3. So the number on the left, 4,193, is greater than the number on the right, 4,103. Again, it's in this tens place that we're able to make that comparison. I can apply multiplication of fractions to word problems. A recipe calls for 3/4 cup of water. If I plan to use the recipe 3 times today, how much milk will I use? Whoop, we have a little error here. This should say water. How much water will I use? And I need to check all of the expressions that I could use to solve the problem. So if I'm going to use 3/4 cup of water and I need to do it 3 times, then it's going to be 3 groups of 3/4. That would be represented here at first as repeated addition. It would also be the same thing as saying I need 3 times 3/4. Here, it's just the commutative property, 3/4 times 3. 1/4 plus 3 is not going to work. 4 minus 3/4 is not going to work. Neither of those are representing 3 groups of 3/4. And neither is 3 times 1/4. That's 3 groups of 1/4, not 3 groups of 3/4. So only the top 2 are going to work for this problem. Now I want to solve. So 3/4 plus 3/4 plus 3/4 is equal to 9/4. Which I know is also, if we want to take this as a number bond, that would be 4/4, which is a whole, another 4/4, so that's another whole, and 1/4. So that would be the same thing as 2 and 1/4. And again, both of these have to be equal to each other because we said the two expressions were equal. Next, I can express a fraction with denominator 10 as a fraction with denominator 100 and add like units. So I'm going to express this fraction 5/10 as a fraction with a denominator of 100. First, I'm modeling the 5/10 by shading in 5 of my 10 parts. And now I want to show how those tenths can become hundredths. I'm going to decompose each one of my tenths into 10 equal parts. When I take 10 parts and I decompose each one into 10 more parts, I end up with 100 total parts. So we now have 100 total parts, and we see that the 10 that were shaded has become 50 shaded. So 50 1/100ths is the same thing as 5/10. And when I add that, 50 1/100ths plus 15 1/100ths is 65 1/100ths. All right, now for the back side. Pieces of rope were measured to the nearest ½ inch. The measurements are listed below. I notice my measurements are between, let's see, the lowest one appears to be 1 1/2, because 3/2 is the same thing as 1 1/2, and it goes all the way up to 2. So I'm going to start at 1 and I'm going to end at 2. Now I've represented a whole, and since my measurements were measured to the nearest half, I'm going to use halves as my units. I'll break that whole into 2 equal parts, and if I start with 1, then in the middle is 1/2, and 2 is the same thing as 1 2/2. Now I'm going to plot an X above the numbers each time they're represented in my data set. So I have 1 1/2. I have 3/2, which we said is the same thing as 1 1/2. I have 1 1/2 again. I have 1 1/2 a fourth time. I have 2. 1 1/2 is represented a fifth time there, and 2. And again, that organizational strategy is plot the X and then mark it off so that we can keep track of where we're at in the data set there. What is the difference between the longest and shortest pieces of rope? The longest piece of rope measured 2, and again it was to the ½ inch, nearest ½ inch, so our units are inches. 2 inches minus the shortest piece of rope in our list was 1 1/2 inch. And so when we subtract 2 inches minus 1 1/2 inch would be a ½ inch. And we know that 2 inches is the same thing as 1 2/2. And when I subtract 1 1/2 from that, then I'm left with 1/2 inch. I can identify and construct parallel and perpendicular lines, line segments, and rays. Identify the line below. So a line extends in both directions to infinity. So it's going to have arrows at both ends. And so I see that I have a line RS, or I could say line SR. It doesn't matter the order in which I put the letters because both ends are similar. They're both the same in terms of points. Or they both have arrows that extend in both directions, I should say. Next, draw ray GH perpendicular to line IJ. So a ray has an initial point and it extends in one direction. So the ray GH would need to have the G first at its initial point, and it will extend in the H direction. All right, so ray GH is there, and if I want it to be perpendicular, perpendicular means it's going to create right angles when it intersects. So we're going to create these right angles here. And it's a line, so it's going to have arrows at both ends, and we want it to be called IJ. Next, draw ray AB parallel to line segment CD. Ray AB. Again, a ray is going to have a point and extend in the next direction, A extending to B. All right, it's going to be parallel, so never touch, no matter how far extended, to line segment CD. Line segment's going to have endpoints at both ends. Okay, and notice I'm making my line segment equidistant at all points to my ray there, so that no matter how far that ray would be extended, the line segment would never be intersected. They would never meet each other. For my segment, it's called CD, so I need to label the point CD, and they could be labeled in either direction because the ends are the same. Okay, they both have endpoints.